Hi, it's Mrs. Pope, and today we're going to be talking about operations with polynomials. Our goal is to simplify and multiply polynomials, and we have a KC, a key concept, and that is a monomial expression is simplified when these conditions are met. First, there are no powers of powers, so you can't have 2x squared cubed. You would need to simplify that before you can have a monomial in simplified form. Each base appears only once, so if you have x squared, you can't have x squared and then x squared later. That's a base, you need to keep that. And the 2, you would need to keep that only appearing once. All fractions are in simplest form, reduced, and there are no negative exponents. So these are the things that need to be met in order to have a simplified monomial expression. So let's look at an example. Let's simplify this then. We have 3 different expressions here, and we want to simplify them. So the first thing we're going to do is multiply the coefficients. So since this is all multiplication, here's what we're going to multiply. So we're going to have 2 times 3 times 1. So that's our coefficients. Of course, that's just going to be 6. And then let's multiply the like terms, like the a's. So if we're multiplying a to the negative 2 times a cubed, remember when you're multiplying, you add the exponents, so you'll end up with a to the first power, or just a. And now let's look at the b's. Well, all we have is b squared, so that's going to stay the same. And then we have c to the negative 2. That's going to stay the same. So we've multiplied everything, we've combined them so that we have just one base. And now let's put them together. So we have 6ab squared c to the negative 2. You should be thinking, wait, there's something wrong. This is not simplified, and you're correct. The problem is right here. Problem. And the problem is we have a negative exponent. Well, the easy way to get rid of that negative exponent is we're going to throw that entire term in the denominator. Because it's in the numerator, we can throw it in the denominator and it'll get rid of it. So the final answer will be 6ab squared divided by c squared. By putting it in the denominator, we've taken away the negative exponent. By the way, had it been in the denominator and it were negative as well, you would have just put it in the numerator. So you just put it wherever it was not. All right, let's simplify. We have to divide. Remember, when we're dividing, we subtract our exponents. So this is q to the 2 minus 7. So really what we have is q to the negative 5. And then the r, we're subtracting those exponents, 4 minus 3, which means r to the 1. So if we were to write this, we'd have q to the negative 5, r to the 1. What's the problem? Of course, the negative 5, the exponent of negative 5. So in order to get rid of it, we need to throw it in the denominator. So our final answer would be r over q to the 5th. All right, there's a shortcut on how you can do these. I call it where there's more. Let's look at the same example. Q squared r to the 4th over q to the 7th r cubed. One way you could do this is a shortcut. You could say, where are there more? So let's look at the q's. Where are there more q's? Up top or down low? Down low. Okay? How many more? Well, there are 5 more down low. Because there were 2 up here, there's 7 down here, there's 5 more. Where are there more r's? Up top. How many more? There's only 1 more, because there's 3 down here, 1 up top. And if you notice, we get the same thing. So, you can subtract the exponents, or you can take the shortcut and play where are there more. Alright, let's simplify. If we have a quantity inside and we need to cube it, remember the numerator and the denominator are both going to be cubed. So what this really means is negative 2a to the 4th cubed over b squared cubed. Now, of course, it's not simplified because we have power to powers, we have all kinds of stuff we can do. So let's simplify the top part first. Every single piece of this needs to be cubed. So we would have -2 cubed and a to the 4th cubed over b to the power to a power. You multiply, so that's b to the 6th. And here we're going to have -2 times -2 times -2, which is going to be -8. And then a to the 4th to the 3rd, that turns into multiplication. So that's a to the 12th, all over b to the 6th. Now does it look simplified? Absolutely. Okay, here, example 4, find each product. Now we're going to need to use our distributive property. The distributive property is used all the time. So we need to take the 3x and multiply by each of the terms inside. So 3x times 2x squared, 3 times 2 is going to be 6. Remember, that's like x to the 1. X times x squared is going to be x cubed. Minus 3 times 4 is 12. X times x, x squared. 3x plus 6 plus 18x. All right, that's it. Just distribute. Look and see if there are any like terms. There are not, so we're finished. Let's look here. We need to multiply. This one looks like there's going to be a little more work because I have to multiply each of these 3 things by everything on the others in the other parenthesis. So I'm going to take the x squared times x plus 2, and I need to take the 4x times x plus 2, and I need to take the 6 times x plus 2. So I took each one of these and multiplied it by x plus 2. That's how I'm distributing. There are a couple different ways you can do it, and if you find a better way, go for it. All right, let's simplify here. We have to use our distributive, so x cubed plus 2x squared plus 4x squared plus 8x minus 6x minus 12. All right, now let's combine our like terms, and let's take each one and write it as our final answer. So x cubed, there's only one x cubed, so that's going to be part of my final answer. I'm done with the x cubed. Squareds, I have 2. I have 2x squared and 4x squared, so I need to put those together. I'm done with the x squareds. Now x's, 8x minus 6x, I'm going to end up with 2x. Done with those. And the last but not least, I have 12, our constant. So now we have this simplified. All the bases only appear once, no negative exponents, and everything else it said in the beginning to make sure you have to make sure it's simplified. All right, let's look at another example. Distributing. Distribute everything in here, and then we're going to add it to this distributed. So here we go. 10c cubed. See if you can beat me. Minus 15c squared. Did you win? All right, let's see. Check my work. Make sure it's right. 14c squared minus 16c. Looks right. So let's go ahead and combine our like terms. Cubed, we only have one. 10c cubed. That's done. Squareds, I have a negative 15 and a positive 14. So I'm going to have minus c squared. C's, I have a positive 20 and a minus 16. So I'm going to have a positive 4c. Now it's simplified. All right. I believe that was our last example. Yes, it was. Thanks for watching, and remember, you are responsible for your own learning.